this video, we're going to talk about graphs of quadratic equations. And whenever we're graphing something kind of for the first time, I always like to start by plotting points. Now, this is not a line, and the reason it's not a line is because that has an exponent of 2. So that makes it more complicated. And typically, the more complicated the shape is, if it's not a line, I try to plug in 5 points. And I usually start with 0, 1, 2, -1, -2. And if I need to, if those don't work or if they're not going to graph nicely, I'll plug in something else. But I like to start with those points. Okay, so let's go ahead and plug them in for X. I'm going to show my work just to kind of help you follow along. So Y is going to be, okay, so plugging in 0, that's going to be 0 squared times 4 times 0, that's 0 plus 3, so that's going to come out to 3. All right, plugging in 1 is going to give me, let's see, 1 squared is 1. 1 minus 4 is -3 plus 3. Okay, that's going to come out to 0. Plugging in 2 is going to give me, let's see, 2 squared is 4. 4 times 2 is 8. So that's -4 plus 3 is -1. All right, -1 squared. So I'm putting that in parentheses because I'm emphasizing that if you were to plug this into the calculator, you need parentheses. If you don't put the parentheses, that answer is going to come out negative. But what you're really wanting to do is -1 to the power of 2. In other words, -1 times -1, which is +1. And then -4 times -1 is +4. So, okay, so that's 1 plus 4, which is 5, plus 3 is 8. That's okay, I guess, but not liking that too much. All right, let's plug in -2. Let's see, that's going to be +4 and +8, which is 12 plus 3. Wow, 15. Okay, yuck. Don't like that one very much. Okay, so I really don't want to plot the last one. I was kind of looking at nice numbers, though, as I was going in the positive direction, right? 0, 1, and 2. So how about I plug in 3? That would seem like a good number to plug in that direction. So let's try 3. Okay, so 3 squared is 9. 4 times 3 is 12. So 9 minus 12 is 3 plus 3 is 0. Okay, cool. I like that one. Definitely good with plugging in that one. So I'm going to graph these 5. 1, 2, 3, 4. Oh, not that one. Not this one. So these are the ones I'm going to go ahead and plot. I'll ignore that. -2, 0. And let's see, 0, 3, that's going to be here. 1, 0 is here. 2, -1 would go here. -1, 8 is going to go, let's see, wait, that's 3, 6, 2. Okay, right there. And then 3, 0. There we go. Okay, so what I hope you're noticing is if I were to kind of draw this, this is a U shape. So I'm going to try to make that as curvy as I can. And since it's a U shape, I'm going to assume that it's going to kind of continue upward in the same kind of pattern. In other words, if I were to plug in 4, I will bet I'm going to get out 3. In fact, you could check that. If I plug in 4, I should get out 3. And if I were to plug in 5, I should get out 8 and so forth. So the idea is there's kind of like this symmetry going on here. And I like to put arrows on because it's going forever. And this symmetry and the U shape is what we are going to be looking for when we are graphing these. So there's this kind of symmetry across this point, like that low point right there. They call that an axis of symmetry, by the way, when it does that. I'll go ahead and abbreviate symmetry. And this shape, as some of you might be familiar with, is called a parabola. This kind of U shape here that we're looking at. So what I'm interested in is not having to kind of do this guessing thing. I'd like to have a way of graphing these much quicker and much more efficiently. So we tend to stick with some key points of the graph. And those key points we'll see are the vertex and the intercepts. So quick comment. We're looking at equations that are in this form. Oops, that should be a squared. X squared plus bx plus c. So the vertex is the highest or lowest point. Now, in this particular graph and in the one we just did, the vertex is the lowest point. So in this graph, the point D would be the vertex, okay? But it could be the high point if the graph was flipped over. In other words, if we were looking at an upside down parabola like that, okay? In that case, the vertex right here would be the highest point, okay? Now, there is a formula for finding the vertex. I'll do that in blue. And it helps us find the x coordinate of the vertex. And I'm talking about the x coordinate for an ordered pair, since we're graphing ordered pairs. So you could find it by doing x equals negative b over 2a. Okay, then there are what we call intercepts, and this should be a concept you've probably seen before. Intercepts are where the graph crosses either of the axes. So let's say the axes, the plural version of axis, axes. And we do have a special name for it. So when it crosses the x-axis, that's called the x-intercept. Or in this case, intercepts, because I hope you notice that point B and point C are the x-intercepts. And what's special about all the points on the x-axis is that they have a y value equal to 0. And we're going to use that. Oops, let me go ahead and do that in blue. They have y values equal to 0. So when it crosses the y-axis, we call those y-intercepts. But we only have one y-intercept. That would be point A. Excuse me, and that's supposed to be a T. Point A. And points on the y-axis are where x equals 0. Kind of running out of space, just put it next to it. Okay, so up here on my previous example, the vertex then would be at x equals 2, -1. That would be the vertex. The x-intercepts would be at 1, 0, and 3, 0. Notice it's where the y is 0. I'm going to go ahead and abbreviate it. INT. X-INT. And then the y-intercept would be at 0, 3. So the -1, 8 doesn't really play into that, but it is something we see that is slightly useful in getting the kind of the idea of what's going on with the graph. But more useful than that would have been plotting that point, and we kind of did 4, 3, because 4, 3 kind of gives us that balanced symmetry that we see on the parabola. But I'd rather not plug in points. I'd rather find these key points and kind of know what it's supposed to look like so that I can use this to help me graph the equation. So let's go ahead and look at another example. And this time we're going to find these key points. I'm going to start by finding the vertex, which means I'm going to use that formula. X equals negative b over 2a. So for this problem, that's going to be, okay, so -2, oops, just kidding, -2 over 2 times -1. Okay, sorry, that works out to be -2 divided by -2. So I could just kind of apply this negative out in the front up to here. So -2 over -2, which is +1. Okay, so I have the x coordinate of the vertex. So to find the y coordinate, I just need to plug that back in for x. So that's going to be -1 squared. So just the 1 is being squared, not the negative. Because that's not what I'm plugging in for x. The negative is going to float out there in the front. So let's see, that's going to be -1 plus, so that's 5, so 4. So that should come out to 4. I'm just going to go ahead and plot it as I go. So 1, 4 would be right there. Okay, so now let's find, we'll start with the Y-intercept. And the reason is plugging in 0 for X is very easy. I'm just literally going to plug in 0 for X, like how we did above when we were plotting the points. That's just super easy to plug in for X. So plugging in 0 for X is going to give me 3. So that is the point. Oh, here, I should have written out the fact that the ordered pair here is 1, 4. 1 for X, 4 for Y. So here I'm getting the ordered pair 0 for X, 3 for Y, right? I plugged in 0 for X, I got out 3 for Y. Okay, so 0, 3. So that happens to be the same Y-intercept that we saw earlier. Okay, now let's do X-intercepts now. So X-intercepts is when Y equals 0. So the Y is on the left side of the equation. So plugging in 0 for Y kind of changes things. So in order to solve this, I'm going to need to factor. Now, there's a negative in the front of the X squared, and there's a couple ways I can handle it. I could just move everything to the left side, like literally flip all their signs, or I could factor out a -1. I'm going to go ahead and just move everything to the opposite side because I think most students are comfortable with that. They're used to having it on the left and the equals on the right. So let's factor this puppy here. So that's going to be -3 and -2. Two numbers are multiplied by -3. Add to be -2 is -3 and 1. X minus 3, X plus 1. So when we set those equal to 0, I get X equals 3 and -1. So that gives me 2 ordered pairs. It gives me the ordered pair 3, 0 because I plugged in 0 for Y, right? Like that was the first thing I did. I plugged this in for Y. And then the other ordered pair is -1, 0. So I'm going to plot that. Okay, so -1, 0 is here. 3, 0 is here. Okay, I can see the symmetry around the vertex, and it's upside down. So I could kind of tell that this point, right here, I'll do it in a different color. This point is probably like the symmetrical to that Y-intercept there. So I can kind of just plot it. Now it's upside down, and I could have been able to tell that from the fact that at the very beginning, the leading number is negative. So when A comes out negative, we get an upside down parabola like this. When it's positive, like it was the first one we did, it came out right side up where it was facing upward. Okay, let's try another one. So for this one, starting with the vertex and our little formula, this time we have, okay, -12, which becomes a +12, right? The double negative. And then 2 times 2. So that's going to be, right, so here that's +12 divided by 4. Divided by 4 is 3. Okay, so I can get X equals 3. So I'm going to plug that in to the Y, or to find the Y. 12 times 3 plus 10. Okay. Should probably make sure I check this on a calculator, but I'm going to attempt to do it in my head. Let's see. So that's going to be 3 squared, which is 9, times 2 is 18. And then that's -36, which should be -18. And then plus 10 should be -8. Okay, not too terrible of a point. 3, -8. 1, 2, 3, and then -8 should be here. Let's see. 2, 4, 6, 8. Yeah, okay. Kind of hard to tell. So these are 10 by 10 grids. So that's helpful. Anything bigger than that, I kind of tend to try to pick something else if I can. Okay, but because we're kind of using these formulas, they tend to be nicer numbers for us for this reason. Not always, but they tend to be. So let's look at the Y-intercept again. Next, I'm plugging in 0 for the X value, which gives me And if I hope you notice that it basically gives you the last number there, right? The C. So 10. So there's the point 0, 10. Wow, 0, 10. Okay, that's way on the other side here. So that's all the way up here. 0, 10. All right, let's go ahead and try to find the x-intercepts now. Plugging in y equals 0. So that's going to give us 0 equals 2x squared minus 12x plus 10. Okay, so rather than move everything to the other side and make it a negative, I'm just going to literally boop, put the equal 0 on the right for factoring. Okay, but actually I can factor out a 2. I have a GCF of 2. So that's going to give me x squared minus 6x plus 5. And then I'm going to go ahead and factor this. Oops. My computer is acting up a little. I'm sorry. I have to replot that. I might have to replot the top one. Yep. It's getting pissed at me. Sorry about that. It's a picture. So if I touch it, it gets pissy. Oh, I even moved it. That's why. All right. Hold on. Let me attempt to move it back here. All right. Sorry about that. That made the video annoying. I apologize. So then we go. Try that again. So that was 3, negative 8. It's right here. And then up top, 0, 10. Sorry, guys. All right. So let's factor this. So that's going to be 5 at the top, negative 6. So two numbers that multiply to be 5, but add to be negative 6 would be negative 1, negative 5. And I ignore the 2 when I'm doing this. 2 can't be set equal to 0. So I am getting positive 1 and positive 5. So there's my ordered pairs. 1 for x, 0 for y, 5, 0. Okay, so let's go ahead and plot that. So 1, 0, and 5, 0 would be right there. All right, so there we go. So it's kind of a skinny parabola. And I have symmetry right here at that point. So sloppy. Okay, it just got worse. So that's kind of, I'm just having so much trouble. We're just going to ignore the fact that that point's there. There we go, as best I can. Big arrow. Okay, there we go. So there's our plot. Hopefully you didn't struggle with it as much as I did, but that's what we're going to do. We're going to find the vertex, find the intercepts, and kind of graph them on the picture as best we can. Some of the questions just ask for the vertex and the intercepts, and then which way the parabola is going to face, like whether it's up or down. But for the most part, I want you to be able to do these plotting points and drawing it out to the best of your ability. Hopefully, it's better than mine.